Man.
Hello everyone. Today, welcome to. Oh, wait me. I need to monitor the stream a little bit. Okay, I think everything look good. Uh, let's see Discord. Okay. So thank you everyone for joining with us today, and let's hope we can learn some from Jonas. He came from MagicBlock, and Jonas, can you tell us a little bit about yourself and introduce us to MagicBlock? Uh, can you hear me well? Am I mute?
Yes, hey. Can you hear me clearly?
Okay, yeah, I think it's good now.
I can hear you. Can you hear me? Hello?
Uh, y-
Can you hear
your
me?
lip does not match with your sound,
Can you hear
so
me?
maybe there's a little bit of
I can hear
lagging.
you
I can
well.
hear you. I can hear you. I can hear you.
You?
Yeah, I think it's just an internet issue that lagging. Okay. I think Jonas just have a little bit of technical issue. So while waiting, we can do an announcement like we start with the PSG one competition. Basically, you post on the community forum. I don't think it's forum. It's just the X community, and only the team that actually submit on the submission can join the competition. So basically, I want and then we also have the Solana Gaming can help with the engagement and increase the retweets and promote you on X, and that's it. So if you want to join, follow the submission form, fill it out, and oh, I think I see you. I see you showing up, but it's spinning. Jonas' Wi-Fi just dropped, so I think we will have to wait a little bit. And anyway, the PSG reward we keep out two PSG. One is the limit edition, and okay, let me share the screen. Uh, so if you want I think they just announced today the PUBG. The B, can you help me with the screen? Okay, let me copy. Okay, so anyway, if you guys want, I think they just released this like a PUBG Play Solana. So if you want one of the limit edition, uh, we have like the first prize will get the limited edition. Of course, you can pick whatever you want, and the second prize will be the Play Solana Genie one original. So I think this just these two. So if you build the game or like you want to test play the, and then this is a perfect opportunity for you. And so join the game jam for the cool PSG one. Okay, finally.
Wow. This $349. Hello, can you hear me?
Yes, I can hear you.
Oh, awesome. I'm so sorry. My Wi-Fi has some issues. Usually it doesn't happen, but yeah, I guess Super Team Vietnam cracked my Wi-Fi and hacked into it.
Oh, yeah. Okay, so can you tell us a little bit about yourself, and we can start with the watch on this today talk about MagicBlock.
Yeah. Thank you so much for inviting me to talk about MagicBlock. My name is Jonas. I'm with MagicBlock in developer relations. I've been in the Solana ecosystem since 3 years, building a community, Web3 community in Singapore with MetaCamp for the last 3 years. And I'm more than happy to show more builders and enthusiasts on how real-time applications work on Solana and how you can integrate it. Yeah. Do you want to say something or should I go right into it, Ipo?
Oh yeah. That's awesome. So let's we can go straight into it. Do you want to share your slide? Is it okay if for you to share the slide on your like internet? If it's not okay, then I can share my side.
All right. Yeah, I have some slides for you guys to get there. Yeah. Let me see. Maybe I can also share on my side. Let's have a look. Can you see my screen?
Uh, B, can you help with
Do you see my
the
screen?
screen? No, I don't see it yet.
Hello?
No, I haven't seen it.
Can you see my screen?
Let me
Ipo,
call B. Yeah, yeah, yeah.
can you
Let
see
me
it?
call the. No, no, I haven't seen it. No, I can't. I don't see it.
Hello?
Can you hear me? Oh no,
Yes, I can hear you, Ipo. Yeah, can you see my screen?
no, I can. Why? But why? I think it's spinning for me. Uh, you disappear. I can hear you, but maybe it's better that I share your screen. Uh, okay, I have no idea how to. Okay, is this? Yeah. Okay, maybe I can pretend myself to be Jonas and do the presentation.
All right. I hope this works now. I don't know why, but this internet is really, really bad. Can you hear
Well,
me now?
sometimes, yeah, it's okay. Sometimes things happen and nobody know how understand how it. Like, yeah. Okay. Anyway, do you want to start with
Can you hear
the
me
slide? I
clearly now?
can. Yeah, yeah, yeah.
Okay, okay, yeah. Thanks, Ipo, for sharing the slides. Maybe this helps for the internet connection. Yeah, let's dive right into it. Hope all of you have heard about MagicBlock. MagicBlock is a ephemeral rollup on Solana for real-time private and institutional grade decentralized applications. So today I'm gonna share a little bit what MagicBlock is about, why you should maybe use MagicBlock, why you should not use it, how it works, and how you can integrate into it. I will also do a little demo for you to see how you can integrate it and show you also some code examples. Just to double check, Ipo, how many minutes do we still have left? So I may need to run faster or like can take my time depending on which part.
You can. We have like all the time you need. So
Oh,
I
really?
don't know
Okay.
about the audience, but like I will be here with you, like forever
Okay.
for you. So don't worry about the time. So
All
the
right.
audience, the audience gonna come and go, but like I will
But
be here for you. So don't
what,
worry about
what,
it.
what, where's the audience from and how long are they in? Just to double check.
Okay, they are in Discord now, and most of them are
Mm-hmm.
in the Discord. So
Okay.
some on the X and YouTube. So we are streaming on X, YouTube, and Discord.
Awesome. Okay, then we have a global audience. Great. And how many, what's the time that we have promised them? Like 1 hour?
There was a workshop we reached to 2 hour, and like
Okay.
it depends because sometimes like people like to chat and like asking question.
All right. All right, let's
Yeah.
do it then. Let me try to be fast so we give also some time for Q&A. I think that's more the exciting part to help the others in specific questions. So let's dive right into it. So yeah, these are the 4 topics that we're gonna talk about. Why MagicBlock, how it works, demo, and what's next. Let's go for one, why MagicBlock, the next slide. Next one. Yes, next one. Yeah. So MagicBlock has started out as like supporting on-chain games with Bolt, for example, the framework, which helps to like an anchor framework, which helps you to build games modularly, very easy by reusing modules. But what we have discovered, and that's why MagicBlock ephemeral rollup exists, is once you have like a game on chain, on the left side, you can see on Solana without MagicBlock, this laggy experience where you have for every transaction that you make, you can update the state of this ball where it moves in the game. And we realized that 400 milliseconds is actually not good enough to provide a really good user experience in gaming as we know it in Web 2. So on the right-hand side, you can see with the MagicBlock engine, Supersize is using us to build this game. And you can see it's lag-free. And also not every transaction needs to be submitted on Solana and be paid. So here we have this ephemeral rollup where all the transactions are routed to, where you have like sub 10 milliseconds and where you can customize your fees or pay no fees and only pay fees when you distribute, let's say, rewards to your users on the main chain. So with that, you can build unstoppable applications such as games on Solana. And this is why we started out with the ephemeral rollup. And that's why where we also discover more and more use cases. So if you go on to the next slide. Yeah. We have discovered also other use cases where we believe that the ephemeral rollup can help developers, projects to build real-time applications. So other use cases are DeFi, when you want to, let's say, stream data on chain, let's say price feeds from PIF laser, which is like 1 milliseconds um, per price feed, every price feed one like every millisecond. You need to have a chain that can handle it. And here with the ephemeral rollup, you can push the price, consume the price, and applications such as Flash Trade are integrating with us, but also D-Telecom is a deep-end application for streaming or like voice calling on chain. So they're using us to enable unstoppable high speed or in real time decentralized applications. But also like other more complicated games, complex games such as MMORPGs are also use cases. So it's really the creativity is your limit. Going next. The benefit what we provide for MagicBlock is we want to provide the performance and the scalability and the cost advantage of centralized like systems, such as when you use AWS, Azure, or even your own computer, with the benefits of the whole decentralization blockchain aspect on composability, verifiability, and ownership. And if you bring these two benefits, like the best of the two worlds together, you will find MagicBlock. If you go to the next slide. So we have some other games and some other applications where we see that the integration with MagicBlock provides significant value propositions. Number one, obviously, no platform risk. So there's no Google or no other intermediary to kind of like set the barrier for you to join and increase the cost if they don't like you or kick you out if they don't like you. The game that is built on or the application that is built on chain is unstoppable. It will live there forever. You can see all the resources available and verify that. And you can compose different assets from different games and other applications all together. and access DeFi. And also you can allow other people to build permissionlessly on top of your game, such as different mods. So these are all the advantages that you can gain by building your application on the blockchain with MagicBlock. If you move forward, what we also provide in our stack is we have some plugins that help you to enhance your application. So these plugins are, for example, what I mentioned, the price feeds. We have a built-in crank, which is not really possible in Solana right now. We have a high precision clause, which is much more precise than 400 milliseconds. We have verifiable randomness functions that you can utilize in sub 10 milliseconds. AI oracles for NPC, non-performing characters, and we can help you to, or with MagicBlock, you can customize your fees as users will play or like use your application. You can set your own token or custom fee amount for users to use your application in real time. Moving on, yeah. So overall, the reason why ecosystem partners are choosing us is because one, we provide lower cost. Significantly lower. I will share with you how much lower. Number two is we are 40 times faster at least compared to 400 milliseconds. And we can allow also private transactions. If you move on. So let me show or share with you how it works. So we have this Solana blockchain that produces on this road like every 400 millisecond a block, right? So if you go to the next slide, how you can imagine MagicBlock is we have a highway. And you can go on this highway, and with this highway, you are much faster. You have 10 milliseconds. You produce every block, but in the end, it will merge back to the main road, which is the Solana blockchain. If you go to the next slide. So we are kind of like this extended SVM engine, as you can like kind of like visualize, with a global state infrastructure, a lot of L2 solutions. We are not a L2, but a lot of L2 solutions require you to deploy programs on the main chain, but also on the L2, and forces you to bridge assets if you want to kind of like be compatible. And the problem is you cannot access the liquidity or the states from the L1 to the L2. With MagicBlock, you can do that. You can make composable apps and in a high-speed environment. Go to the next slide. Yeah, so this is how it kind of also looks like visually. Every 10 milliseconds, you can think of a block is produced, which is real time, while Solana produces 400 milliseconds. So on MagicBlock, when you produce 40 blocks, you can merge the 40th block back to the second block of Solana because of the speed of MagicBlock. And you can sync the state continuously on MagicBlock to Solana and read the state from Solana to MagicBlock just in time. So how does it work? There's this concept of delegation that we use in order to bring your application on the high-speed way. How we do that is by number one, you need to delegate an account on Solana, which is usually a state account that you want to enable sub 10 milliseconds of state transitions. The delegation, what it means is you change the owner of the PDA to the owner of delegation program of MagicBlock, which will then basically lock your state account. And with that, it's available on the ephemeral rollup. Number two is you submit a new transaction that you usually submit. Usually don't need to change the transaction. You just submit the transaction that you usually submit on the main chain, but it will be routed to the ephemeral rollup. And with that, it will be executed in real time on the ephemeral rollup with sub 10 milliseconds. And once in a while, you may want to commit, meaning the state of the ephemeral rollup of that account should be synchronized on Solana. You can basically commit that state. Or if you feel like, oh, I need to take the ownership back to the original program and should go back to the 400 milliseconds kind of like environment, then you can undelegate it and then the state will be also committed. So these are the three things that you should think about when you want to bring your applications to real time and back to Solana. Next slide. And how you're gonna do that is, so you need to enable your program, your existing Solana program with some superpowers, some magic lines. It's just a few, depending on whether you use Rust Native or Anchor. We support these two frameworks. the native one in Anchor. And how it works is you have your existing program. Let's say you have a counter program. Let's say you have like a game or like whatever program you have. What you have to do is you use the existing program as it is, so you don't need to like delete any code. You just need to add a few codes. So here, these are the codes that you add depending on which part we are addressing. So on Rust Native, let's have a look there. So if you want to do CPI calls on Solana, basically to delegate your program to the delegation program, to delegate the state account to the delegation program, you have this ephemeral rollup SDK, and here you have like different functions that you can use to call CPI to the delegation program. And then for the ephemeral rollup, there are also some CPI calls that you need to basically commit the states once the state is basically committed to the ephemeral rollup, delegated to the ephemeral rollup. When you want to bring it back, you need to call a CPI from on the ephemeral rollup. So that's why there's a different module here, the FM module used for the ER CPI calls. So these are also just functions to help you to make CPI calls. You just put in some inputs and then you're good to go. For Anchor, we have some macros available from the ephemeral rollup SDK. We have the delegate, ephemeral macro, and the commit macro, which you can just add to your usual program, and then it will just work like magic. And it basically you are compatible with MagicBlock's ephemeral rollup. Yeah, I will show you an example later on how it looks like for you to give like some sense. But for now, yeah, just the gist is here. We have one SDK for you, the ephemeral rollup SDK, and you just need to add a few macros or a few lines of code to enable the CPI calls on Solana and on the ephemeral rollup. All right, the next slide. What we are currently working on, which has been already launched, is the Magic Router. So what we want to enable is a user experience that is seamless and to make your transaction smarter when you submit it. So I mentioned that when you submit a transaction on Solana, and if you want to integrate with ephemeral rollup from MagicBlock, we want to make it seamless for you. So how it works is you should only submit a transaction that you usually submit and don't have to change it. So that's the scenario that we are kind of optimizing. You don't have to change anything about the transaction. It will work magically on Solana and accelerated on the ephemeral rollup. The only difference is before you submit a transaction on the ephemeral rollup, your account needs to be delegated. That means you need to basically send a transaction beforehand to delegate the account, and then the subsequent transactions look the same as if you would send it on Solana or on ephemeral rollup, and it will just know automatically or execute accordingly. So if you go one slide later, so when the user submits a transaction, this transaction should be indifferent, and the Magic Router, the RPC node, should basically know where to send it to, and we don't want new infrastructure to be added to the ecosystem, but use existing infrastructure. So you should have, let's say, when you have a Helios RPC endpoint, you can just use your Helios RPC endpoint to do whatever you want to do already to integrate with MagicBlock. So that's basically the idea that we're having behind. Moving on. Yeah. So this is the whole life cycle, how it looks like. So when you submit a transaction to the Magic Router, it will basically detect what kind of transaction you are actually submitting. So if you send a delegate transaction, it will delegate or route the transaction to Solana. With that, your account will be changed, the owner to delegation program, making it available on ephemeral rollup. When you submit another transaction, basically update a state, then the Magic Router would know that it's supposed to go to the ephemeral rollup. So it will execute the transaction in real time until you want to commit. Then it will basically sync the state. And after you basically undelegate, then this transaction that you sent to the RPC should be routed to Solana. And with that, yeah, you work as usual with Solana on the mainnet. Yeah, so this is the life cycle. The economics, the cost here behind is, so what we're gonna do is for public or shared ephemeral rollups, we don't want to charge any transaction per SOL, any SOL per transaction. So your transactions are free. But what we do is we charge initial amount, which is the session fee. So when you delegate your account, we basically will charge you 0.0003 SOL for the delegation. And with that, you will pay no fees when you submit transactions on the ephemeral rollup. And once in a while, you may want to synchronize the state from the ephemeral rollup to Solana. Here we charge this commit fee, which is like 0.0001 SOL, basically to bring your data from or your state from the ephemeral rollup to Solana. We do offer also dedicated ephemeral rollups for like projects that require high volume on high speed like transactions. Basically, they have like hundreds or thousands of transactions per second. Here, the shared infrastructure, like a shared node for the ER, may not be viable for them. And in this case, we will charge per transaction around 500 LAMP pods, which is 10 times cheaper than on Solana right now with 5,000 LAMP pods per transaction. But in this case, we guarantee that the transaction will land whenever. While on Solana, I think if you add priority fees together, it can be like 4 times more expensive to land a transaction. So this is the economics. This is how the token of MagicBlock will also accrue value. So later, towards the end of this year, we will have a token, which basically where we give revenue back to the token, and that's kind of the appreciation value of that token that we're gonna launch. So stay tuned about that. Next slide. Yeah, delegation flow. Let's go a little bit more detail for those who are looking to integrate with MagicBlock. If you go next slide. So as I mentioned, there's this life cycle. We first delegate, right? When you submit a transaction, the RPC will see your account is undelegated, so your transaction delegate will be processed on the base layer, which is Solana. Here, the owner will be changed, your account from your original program to the delegation program, and then you will have like a successful transaction submitted and confirmed on Solana. Once you did do that, actually at this point of time, your account is not delegated or not available on the ephemeral rollup. You don't see it yet. It will only be visible once you submit the first transaction on the ephemeral rollup. So with the second transaction that you send for real-time execution, here your accounts that are delegated or like are writable are all delegated, meaning the owner is the delegation program. Here, this transaction will then be routed on the ephemeral rollup, and then the transaction as it is, as you would send it usually on Solana, will be executed. And with the first transaction, the undelegated or the newly delegated accounts will be cloned and then executed. And then you can submit as many transactions as you want. It will be executed as if it would be on Solana, but much faster, and depending on the fees, no fees or much less. And if you go to the third slide, or this the next slide, if you commit or undelegate, here there will be a schedule created on the ephemeral rollup to basically get the state, finalize the state, and update the state on the base layer, or even reset the owner to your original program if you undelegate. So this is how the whole information data flow works in between the RPC, the Solana base chain, and from a rollup Solana MagicBlock. If you go to the next slide, I think we're gonna do a demo. Let me share with you Ippo, like a link, so maybe you can share that too. Or you can open up the link. Or maybe in this case, let me try to actually share my screen. Is it possible? Can you see my screen? I'm so happy that our connection has been still active since then. I hope you have been hearing me clearly. All right, you can see my screen. That's great, right? Can you? Ippo? I don't hear you. You're muted.
Oh, I need to call the admin of the stream a little. So wait.
Okay. All right. But so far, everybody can hear me. Am I audible? Yeah.
Okay. It's good.
Awesome.
It's good.
Great. So let me show you this application. So we have built like a. So here you can find this is a front end towards a application that is like a counter application, and this is on DevNet. I'm connected with my wallet, Jonas. Okay, and you can see here on the left-hand side we have a counter which is right now set on 724. I can click on it, and with that you can see a transaction is confirmed to basically increase the counter. So you can see it takes a while, like it loads a bit, right? But then you can delegate this state to the delegation program and then make it available on the firmware rollup. With the first transaction, it takes a while, like 7, yeah, you saw it took a while to confirm, but the subsequent transactions are much faster. You can see it's like significantly faster here. And then I can go back again, undelegate, and then it's again much slower. So this is basically the performance improve that we provide with MagicBlock on Solana to allow your application to run real time just by adding a few lines of magic code. So let me show you how this basically works. So if you go to the next slide, so I'm showing you, let me see, hopefully this works. Let me go just real quick to the demo. So here I have this a QR code. So if you want to check out where I get the code from, it's on our GitHub repo, MagicBlock Labs, MagicBlock Engine Examples. So it's here. This is the code. You can just take this URL. I'm gonna share this also with Hippo. So you can download the repo if you want to try it out by yourself. Here you go. So I have downloaded the repo. I've also made some adjustments to it, but mainly the components are the same. So let's look at the Rust counter. You can see here there are different examples: anchor, a minter, a bolt counter, dummy, token transfer, and so on. We're gonna look into the Rust counter to just show you how it works in detail. The program that we have is here in the source folder. We have some test script that we're gonna run in order to see the performance. In the program, you have basically the first thing is the entry point. This is where all the Solana programs start. And then we process the instructions. So we have our instructions here. Boom, boom. So we have a few instructions. We have like initialize counter, we have an increase counter, we have a delegate, commit, undelegate, commit, and some other fancy functions or instructions where we increase and commit at the same time, meaning we increase the counter but sync the state to Solana, or increase and undelegate. So these are like hybrid or combined instructions. And yeah, these instructions you can find here also. These are the discriminators that we're gonna use: 0, 1, 2, 3, 4, 5. They have some payload, some of them. Yeah, but let's go back. So this is usually your normal instruction. The process of initializing the counter here. We go through the accounts, they come in, we check the PDA, we check whether the seed is valid, PDA is valid. We see whether the account already exists. If does not exist, we get the rent, the size of the data that we're gonna put in, and get the rent to make it rent exempt, or the deposit. We invoke the system program and create the account here, and basically give the owner to our program, and we set the value of our counter PDA state or account to 0, and we serialize it and put it back. So that's initializing. We have an increase one, also normal. Nothing is like MagicBlock right now, right? You have here, you go through the accounts, you check the PDA, and then you increase by whatever amount you put in the payload. So usually is by 1. And then you serialize and save it. So this is your normal like program. It could be something else. It could be a transfer. It could be like a game that you have, like move the player, whatever. But now, how do you integrate with MagicBlock is you use like instruction that is called delegate. So you can see here we have an instruction called delegate. So what it does is it takes a few accounts inside. So visualizer system program PDA, the PDA that you want to delegate, right? And then some delegation accounts. So that's the shape of the account. And we basically here prepare the seeds of the PDA that we want to delegate. And then we have a way for you to basically create the account structure, the writable, like the account meta and so on, for the instruction that we're gonna use to create the CPI call to the delegation program. So here we also set a config, how many times per like 330,000 milliseconds, where we commit the state automatically from the firmware rollup to Solana, or you can set it shorter. We have a validator that we choose because the firmware rollup is hosted on a validator. So here we have a European validator, we have an Asian validator or US validator that you want to work with. So it's closer to your region to enable low latency delegation. And this function is basically, in the end, you have your the accounts, you have your seed, and you have the config. And this creates the CPI call, and this makes the CPI
Can
call.
I ask a question?
Yes.
Is a validator you have to pay for it, or like is it free somewhere?
This is the public one. It's the shared one. That's free.
Oh,
That's the one that I referred to when I was talking about. Where is it? Here. So here you don't need to pay anything.
oh, okay.
So this is this one, yeah, the shared one, and you only pay for the sessions that when you delegate that account once, and then once you delegate it, you don't pay anything, and then yeah, that's it. So it's like if you calculate it, it's like around this one is around 0.01 cent. Okay, it's like very, very cheap. This one, if you put it on Solana with Proud, is like 1 cent per transaction, roughly. Yeah. So here you can make 100 transactions, and that would just cost 1 cent, which is a really good cost advantage. Thanks for the question, Ipo. So yeah, once you delegate it, so this is the delegation of your PDA. So with that, it's already like available or can be made available on the firmware rollup. So then next time when you submit a transaction, let's say this one, increase counter, the router will automatically know it goes to the firmware rollup and will be executed on firmware rollup without any changes, right, of your transaction that you usually have. You can do it whatever, 100 times. You pay 1 cent for every, like in total for the transactions, or 0 if you use a shared node. And then you can decide to either undelegate, or you can decide to just commit the state. So meaning let's say the state was initially 100, and then you increase to 200, and then you want to commit the state 200 to Solana. So you use this function to do that. And here, in both of these functions, they look very, very similar. So we have a few accounts that we put in, and then we basically just use this function that we import, and you undelegate the account. Or here, this is the function commit account, so you commit the account. Yeah, or you can also commit and undelegate. One thing, sorry, I totally forgot. So you may ask, what's the difference between undelegate and commit and undelegate? So this function is used when you undelegate on the firmware rollup. So that means if you want to update the state and undelegate, so meaning bring the owner back to from the delegation program to your original program. So this is a function called on the firmware rollup. This function undelegate is the actual undelegate. So this is called on Solana. So once you submit this transaction where you commit an undelegate, what happens is on the firmware rollup, there's a validator that will process your transaction where you commit and undelegate. And what this validator does is it will submit a CPI call to Solana, and it will pay for the fees of updating the state and changing the owner back from the delegation program to the original program. And how it does is it will call exactly this standardized. So what it means standardized is if you look at the instructions, this undelegate instruction, which is this one, undelegate, it has a specific how to say, discriminator. So this discriminator is fixed. This is used when the ephemeral rollup validator submits that CPI code to really change the owner back to your original program. So yeah, this you basically can copy and paste. This one is basically if you want to do something before you commit, or if you want to do something where you undelegate, you can basically add new features into it. So here, for example, I wanted to increment first here before I call the CPI to commit, or I can also increment and before I call the CPI to commit and undelegate. Yeah. So this is how it works. Go ahead, Deepo.
Yeah, so I really like your comment on everything, and you organize in a very easy way to read the code. And yeah, like so in order to use a function here, like do I just like how much installation, like starting from scratch to like is this like a the process instruction? Do I so I copy paste this and then put it in the whatever I'm doing? Do I need to install
Yeah,
library, or like what is the stuff?
yeah. Oh, sorry. Yeah. Thanks for mentioning that. I totally skipped that. So here we have a SDK. So ephemeral
Yeah.
rollup SDK. This is the one that you use for MagicBlock integration. And once you have this, you can basically get these functions that will make the CPI calls for you. Here, this FM is basically means that the functions that you create or CPI calls are executed on the ephemeral rollup. And then we have the CPI. These are basically functions or CPI calls that are called on Solana, on the main chain. So you can see here, if I use delegate, undelegate, these are on Solana, right? You have your program, you write it out, and you can just copy this function. And you can see here, this function has this delegate account, which is basically imported through the ephemeral rollup SDK. And with that, you can delegate any account. So here you can delegate counter account, or like whatever account you want to delegate that you want to be available, make it available on the ephemeral rollup. And this one here, you see the function undelegate account is also imported from the rollup SDK. You can just exactly copy this function, and with that, basically the ephemeral rollup validator can call your function. But obviously, you need to make your program, the interface needs to be created for the ephemeral rollup validator to call your program with this right discriminator. So you need to make sure that this is also copied. And with that, you can
Can I
delegate it and undelegate it.
see
Yeah,
the test file?
that's
Can
fine.
you run the
Yes.
test? And I just want to see like how it like look like on the test.
All right. So let's just run the test first, and then I go
Yes.
through the test. I have a few things here.
Oh, that's really fast. Like yeah. Oh,
Yeah, we can
nice.
see here, right? You have like some speed comparison. So let me show with you first the test that we have. So we have actually three like bigger tests. So one is this one you can forget. This is what I'm working on right now to integrate the magic router, but you have here the normal test and kind of like a hybrid test. Each test we have like different things that we're gonna do. Here we import basically the key pair, the program ID, and so on. We set the connection for the base layer in the ephemeral rollup. So I'm right now in Germany, so this is now set for EU. And this also, since I used here in my processor, here you go, where is it? When I delegate. So I'm using the EU validator, basically. but you can also use Asia. For people in Asia or US, you can use the US one, but then you will also change basically your endpoint accordingly. We have DevNet EU, US, and Asia, which is DevNet-AS. In the future, the idea is you don't have these different endpoints. You just have one endpoint, but that one we still are fixing some or we improving some of the performance issues that we face. Here you import your user key pair. You airdrop if you need Sol. You basically derive the PA for the counter account, and then you start with the transactions. Here you create a new transaction. You have the keys that you put in, right? Your account meta. You have here your initialized counter, basically instruction discriminator, which is 0, but here you can see if I want to do undelegation, it's this one, and so on. Yeah, and then you basically create a transaction instruction, you add this instruction to your transaction, and then you send it to the base layer for initializing the counter account. Then we increase it. Also the keys. Here we have the increase counter discriminator that we put in. And then, yeah, will be also sent on the base layer. Then we delegate. These are the accounts that we submit. We have some functions here where you can basically derive the PDA that is required for the delegation. There are a few PDAs that are auto-generated basically with these functions. These are also coming in from the package.json. You have like a firmware rollup SDK that you can use.
So
yeah,
you
and
just need
then
the
program ID,
public
obviously.
key. You just need to public key to sign. Because
Yeah,
I got that.
you just sign with your own key.
Okay.
So sorry.
Oh, it's okay. It's okay. So continue, please.
Oh yeah. Oh no, no worries. So these are basically accounts that are created for the delegation to basically hold the delegation records, like data such as where did you delegate it to, when is the commit, where we basically trigger like some auto commits on the backend for you, like the cranks, and some other stuff. And then you create the transaction, and then you basically delegate it. When you want to increase it on the ER, basically here, we basically send this to the firmware rollup connection. And here also commit, and the state is also a firmware rollup connection here. And then if you want to increase further, yeah, firmware rollup. And then undelegate here also firmware rollup. And then that's it. And then let's have a look on the first part of the test. So we initialize, we increment, delegate, and then we increment on the firmware rollup, we commit, and increment on the firmware rollup, and undelegate. So these are the transactions that we submitted. You can see the performance difference. So for on Solana, we have like 500 to 1,000 milliseconds. We have 1,300 when we do the first increment. Here in this case, it's because sometimes it takes a little bit of time to first copy or clone the account to the firmware rollup, but then it should be much, much faster. Like here, we have 400 milliseconds. Okay, it's also a bit like not too much faster, but it's 20% faster here, or like 50%. And yeah, an undelegation somehow takes a little bit longer because it will be confirmed on the Solana once the state is cloned back to Solana, basically. Yeah, and then we can see here also other tests. Here the base layer transaction takes like 2,000 milliseconds, 600 milliseconds, but then on the firmware rollup is significantly faster. What you can do is also you can also run a local firmware validator, so it's really close to you, so you don't have the latency, end-to-end latency. So we have in our README like a way how you can install your own firmware validator, since it's open source, on your local machine. And I have run this script already, but I can basically start my firmware validator by running this code. You can see here the firmware validator is run on 8899. And then I can run the test also on top of my ephemeral validator with this code. And let me just run, let's say, this test only, just to make sure we run one test. Then we can see the difference. Yeah. So you can see the first transaction on DevNet is 2000. You have 800, you have 1000. And the first cloning takes like 1000 milliseconds because, yeah, it takes a while on Solana also to clone it. But then the subsequent ones is 20 milliseconds, 6 milliseconds, 7 milliseconds. So it's like I don't know, 300x improvement in terms of speed. Yeah.
Oh,
So this is the kind of speed difference that you can get if your server is very close to you. So you have basically enjoy both the benefits of the centralized, which is cost, scalability, and performance, but also you have the benefit of a blockchain, which is about verifiability, composability. Yeah.
so I have a few questions. I saw some
Yeah.
plugin like with the price fees and the VR app. I think it's a how you compare this one with the Chainlink one? Like,
Um, so we have a VRF that we built with our own program. Can you rephrase the question? Can you repeat the question again? What you want to know the
I
difference
saw.
between Chainlink VRF and our VRF, right?
Yeah.
Mm. So our VRF, if you use our MagicBlock, you basically have a response time of 10 milliseconds. So for the user is you can create randomness within 10 milliseconds. You can bring or like you can build your own Oracle AI Oracle on the firmware rollup, which allows you basically to get your non-performing character in the game to respond within 10 milliseconds. So that's the difference that we provide in terms of the value.
Yeah. So also about the RPC, I think I saw a slide about RPC service.
Yeah.
Yeah. Is there a pricing for the RPC? Or
You mean the ephemeral validator, ephemeral rollup validator, or the magic router RPC?
Magic router?
The magic router. The magic router will be free.
But the validator will be like a have fee.
Yeah. So the route the ephemeral rollup validator is basically where you have all your transaction executed, right? And if it's the shared one, it's free because it's free. It's as I showed with you, like per transaction is 0 SOL. But when you delegate and you commit the state, we need to execute transactions on Solana, right? When you commit the state needs to be updated on Solana. And for that transaction cost, we need to charge a fee. Yeah. So that one, whenever you need to create a session or when you want to commit the state back to Solana, there are like a few, like 0.0003 SOL. There's some fees. But then you can run limitless transactions for free, basically, on the ephemeral app. Yeah.
Okay, thank you. Anybody have any more question? We also have the game. So for the slide. So anybody in Discord or X have any question? Or yeah. Okay, someone typing. So
Oh, awesome. What's the price for the game?
it's free.
Oh,
The
okay.
price is $5. If you win, I tip $5 for like everyone that like for the winner of like each workshop. So
Oh, wow. So
Okay.
nice.
So we have a question. Can you brief a little bit more on how we can delegate our meme token integration?
Mm, okay. Um, so if you're a token, we have like a let me share. In our docs, we have like a dummy token transfer where you can basically have a look on like how you can transfer tokens with our delegation program. Um, but the concept is same. So you have a state which holds basically the amount of your meme token or the account of your meme token, and you change the owner to the delegation program when you delegate it. So you delegate the PDA, and then afterwards you can execute any transaction as you would execute it on Solana. You can execute it on ephemeral rollup because it's delegated. It will be executed there, and yeah, and then you can make transfers. You can burn, or you can do whatever, and then you can basically commit or undelegate the state back to Solana.
Hmm.
So it's
Is
really,
that
you have
an
your program already, and you just add the new functions for delegation, undelegation, or for committing. So there's really like just a small change. You add a few magic lines, and then it should work. And if you have any
Hmm.
questions, please like ask in the Discord to us or send me a DM. We will help you to make your meme token project work. So
Oh, nice.
it's possible. So just if you face any challenges, raise it in the Discord, and we'll be there to support you and help you to get delegated and to use our ephemeral rollup in real time.
We have another question. Is it possible to integrate community-driven gamification feature like token-based leaderboard, real-time battle, or staking using ephemeral rollup with a meme token economy?
Yes, of course. We also have like a website for you where we basically help you um, to promote your own game. So you can run your own leaderboard on the ephemeral rollup, but as people would use the ephemeral rollup, that I mean, can I share my screen actually? Possible?
Oh, yeah.
Let me share it. So we do have like so you can run your own leaderboard on chain on ephemeral rollup but then what you also can do is once you basically integrate with us, we can help you to have your game published on our quest.magicblock.app here. You can see here, this is my account, but we work with different partners. We have
Oh,
different
wait,
quests.
the screen is not changing. Let me copy. Uh,
Oh,
yeah, I need to ask the
let
admin
me share
to.
the link. So then,
Okay.
you can share it maybe. Yeah. So this is
No,
the
it
link
is
that I
like
shared.
okay, I see.
Maybe here. This is the link. Can you see it?
Can you share again, and then I will copy and
Yeah. Yeah. All right. Yeah.
okay,
Okay,
just
great.
yeah.
So here we have this quest, right? We have a leaderboard. So let's say you build an application, a game on the ephemeral rollup. What we can do is we can help you to be visible on the leaderboard and also like participate here in our as a partners page. So here we have already some games that have built on MagicBlock. And what we do is we incentivize users to play these games, because when they play these games, they can earn points and rank up in terms of the leaderboard. And once they rank up, we will have something that in the end, at the end of this year, or maybe a bit later, depending on how we go forward, we will reward you. So this is a small hint for farming, but we don't want you to go crazy on this farming. But yeah. I'm ranked 250, not too high. So with that, we can promote your project and help people to use your product and others to use your product. I hope this answers your question and how we
Yeah.
leverage the community, or to help you to leverage the community to utilize your project.
So anyone have any more question? And then we can move to the game part.
Yeah, thanks for the questions, guys. Appreciate it. And please, if you wanna, let me share my screen also.
Okay. Yeah.
For
We have one more question.
okay,
Yeah. Wait.
go ahead.
Yeah. He's typing. Oh yeah. You can ask the last one. Ovi. Just type it in. Do you want to share a screen, Jonas?
I just want to say, if you want to connect with us, you find us on Discord, MagicBlock Discord. I wanted to just share the link, but maybe I can just send you the link, and then you maybe can just share it with them. It's maybe easier. You can find us on X. We're really here to support you guys. So if you have any cool ideas, please try it out and let us know, and we will help you to go through all the bugs. So yeah, just leave us a message on Discord. That's the best way to reach us.
Yeah. Ovi, what's your question? Can you have you type it in? Okay, maybe you already answered his question. Okay, wait, he's typing. So,
No problem.
oh, what about live stream? Like how can we integrate live stream project?
What's a light stream project?
Yeah, I don't understand it too. What do you mean live stream project? Like Twitch or I think Twitch is not game. Yeah, like Twitch, kind of. I think it's
How do
like
you integrate live stream project, like streaming project, live streaming projects? Yeah, I mean, with MagicBlock, you have the capability of updating the state sub 10 milliseconds. So with in terms of that, you could create a live streaming project on the ephemeral rollup. We haven't seen it yet, so maybe you're the one who will be creating it. So you need to figure out how live streaming works on Web 2 and see how you can enable like these updates, like streams on
I think
chain, and I think MagicBlock provides
uh,
the infrastructure for you to do that.
yeah. I think for
You
the
may
speed
you may
for the
face
stream. Okay. Yeah, go ahead, please.
yeah you may face issues with storage. So storage, you need to somehow, because if you store everything on Solana on ephemeral rollup, as mentioned, when you deploy things on the ephemeral rollup, it needs to deploy it on Solana first, right? So you need to pay for the deposits on Solana for whatever you wanna basically have. But then once you pay the deposit and you just want to update the state, that's basically almost free, right? And it's sub 10 milliseconds. So let's say you pay like a deposit, which basically, don't know, like how big that deposit like size is, and then you are able to basically stream from that data account, and you change it on the ephemeral rollup like every 10 milliseconds. I think you could do like a live stream on chain. Yeah.
Hmm.
I
Yeah,
mean, but
it's
there are different
interesting.
design choices. You can do like off-chain data, you can do like a data layer working with another data layer and do like some kind of verifiable hashes to kind of like say, oh, that was on chain. I mean, there are so many ways you can do that, but I think because we have this ability now to update states in real time on the blockchain, um, we are one step closer on making live stream more accessible on chain.
Hmm. Yeah, I think on
And I would
the
love to see it.
Silicon
I would
Valley,
really.
yeah, I love to see it too. I think the Silicon Valley series, like it was like the Pied Piper was for streaming. So
Mm.
okay, so I think we can. Anyone have any more question, and we can move to the game. B, help me with the game. Yeah, B is okay. Thank you. Let's join the game, guys. We got only 2 player now, so I will copy the link and say share it on Discord. And okay, you need the link. Here you go. Uh, I think should we start? How many? So free Sodep, Christian Nguyen, John, Ovi, Bruno, Chris, Vijay. So okay, let's do this. Yeah, that's what easy. Whoa. Okay, John is a winner. Congratulations. Send me your. I think yeah. Okay, I will DM you and give you your reward. So thank you, Jonas, again. It was a great session, and I hope we, you just meet. It's okay. We will have more, and tomorrow you can win something if you join play the game. Uh, so thank you, Jonas, and thank you everyone for joining in.
Yeah, thank you,
Okay,
Ipo,
see.
and hope to see you all guys in real life sometime.
Yeah.
Have a good one. Bye bye.
Okay. Bye, everyone.